how to solve radical expressions with addition and subtraction. So if you don't know what a radical expression is, it is an expression containing a radical sign. So if you don't know what a radical sign is, it looks like this, with a number. That is a radical. So if it has the same index or same radical, you don't need to do anything to it. So in which in here, you just copy the square root of 2, and 4 plus 5 is 9. So what will be 9 with the square root of 2? So in here, another example, it has the same index and same radical. As I said before, if you do not do anything to it, you just copy it. So 3 with the cube root of 2 plus 5 with the cube root of 2, you just copy the index and radical. And again, you just plus this 2. So 5 plus 3 is 8. With the cube root of 3 plus 6 with the cube root of 3, it's same thing. Just do it like the first ones. So you just copy the radical and the index. And 5 plus 6 is 11. So it will be 11 with the square root of with the cube root of 3. That is similar radicals. The same process, but you will be subtracting it instead of addition. So same thing, just copy the radical here, but you will be subtracting the 2, so it will be 1 with the square root of 2. So here, this is the same. You just copy the index and the radical, and you will be subtracting the outside numbers. So it will be 2 with the cube root of 2, like that. So same thing, just minus the outside numbers and copy the index and the radical. Do 4. So it will be 4 with the cube root of 2. So moving on, here on the similar radical expressions. So here we have 9 with the square root of 2 plus minus 10 with the cube root of 2. It is dissimilar because it does not have the same index. So what you will do here is you will leave the answer here because he knows.
Because Tina.
So the answer here is just the same. You won't do anything to it. It is just the same answer because it does not have the same index. So what you will do here is you will plus the two radicals that have the same index. That is 9 with the square root of 2 plus 10 with the square root of 2. That would be 19. The square root of 2 minus 10 with the cube root of 2. And that will be the answer. So the answer is like that because it satisfies the rules of adding and subtracting radical expressions, which is same index and same radical. So here are some examples from the whole lesson. So we'll start from addition. So 10 with the square root of 5 plus 5 with the square root of 5. If it is similar, you will just leave the radicals the same and then plus the outside numbers. So it will be 15 with the square root of 5. So 10 with the square root of 5 minus 5 with the square root of 5. Same thing, copy the radical and then minus the outside numbers. It will be 5 with the square root of 5. Let's try the similar radical expression. So like I said earlier, if it is like that, you will plus the two radicals that are the same index. So you will leave the one with the different index. So it will be 10 square root of 2 plus 10 with the cube root of 3. So like our different examples, you will get the two radicals that have the same index and plus them. And then you will leave the different one later. That will be 10 with the square root of 3 plus 6 with the cube root of 3. And that will be your answer because again, it satisfies the rules of adding and subtracting radical expressions. Wait lang.
Secretary ka, pakasuot mo.
So hello again everyone, and today I want to show you more examples of adding and subtracting radical expressions. I did show you the first ones, but I want to show you more so you can understand it better. So here, 20 with the square root of 3 plus 30 with the square root of 3. Again, if it's similar, you don't need to do anything to the radicand, but you will leave it just the same. And the outside numbers, you will add them. So it will be 50 with the square root of 3. So 15 with the square root of 5 plus 15 with the square root of 5, just same thing, the radicands will stay the same, and you will add the outside numbers. So that will be 30 with the square root of 5. So 25 with the square root of 2 plus 5 with the square root of 2, just plus the outside numbers, and then the radicands will stay the same. That will be 30 with the square root of 2. That's how easy the similar radical expression is in addition. So let's try subtraction again. So here, like the addition one, but instead of adding it, you will be subtracting it. So 20 with the square root of 2 minus 5 with the square root of 2. Again, just leave the radicands. And the 20 and the 10, 25, you will be subtracting it. So it will be 15 with the square root of 2. So again, like the first ones, just leave the radicands and minus the outside numbers. So it will be 1 with the square root of 3. So 9 and 3, you will be subtracting it, and the two radicands will just stay the same. So it will be 6 with the square root of 2. 21 with the square root of 2 minus 3 with the square root of 2, that will be 18 with the square root of 2. And that is adding and subtracting in similar radical expressions. We'll try the similar ones. So to solve these two problems, like in the first part of the video, like I said, you won't do anything to it. So to get the answer of this one, all you need to do is add the two numbers that are similar, which is 5 with the square root of 3 and 10 with the square root of 3. That will be 15 with the square root of 3 plus, because the sign is positive, and then you will just get this one, the one with the different index, and just add it to the answer. That will be 2 with the cube root of 3. And that will be your answer. And why again is that your answer? Because it satisfies the rules of adding and subtracting and expressions, which is same index and same radicand. 30 with the square root of 2 minus 6 with the cube root of 2. That will be your answer. Because it does not have the same index. But if it has another number, like earlier, what you will do is you will add the similar numbers, which is 30 with square root of 2 and 6 with the square root of 2. That will be 36 square root of 2 plus, because the sign here is on the middle is positive, and plus 6 with the square root of 2. That will be your answer. So the answer will be 36 with the cube. So the answer will be 36 with the square root of 2 plus 6 with the cube root of 2. And the answer is like that because it satisfies the rules. Another example, 8 with the square root of 4 plus 10 with the cube root of 4. Like the first ones, you won't do anything to it, just leave the answer. That is the answer itself. But again, if you add another number, like that, you will add the two similar ones, which is 8 with the square root of 4 and 2 with square root of 4. That will be 10 with square root of 4. And again, you will just add the different one on the answer. So that will be 10 plus 10 with the cube root of 4. And that will will be your answer because, again, it satisfies the rules. And that is the similar and assimilar radical expressions. So thank you for listening to my vlog, and I hope you understand something from it. I know it's a bit confusing, but math is very, very easy, and I hope you get something from it. And you can teach your friends what you have learned, and you know, math is fun. Thank you!